Hey friends, I wanted to walk through the very first example of the homework problems for you because I felt like when we left class, what I needed was not 100% clear, and you shouldn't be confused by directions. That's not the goal here. So we're going to be given a standard form quadratic, and we're going to be asked to write it in factored form, and then again with a squared binomial in it. And that's a weird way to say it. We didn't quite get the real form name officially done in class, so the instructions look weird, but hopefully you'll recognize it as we use it. And then I want you guys to use Desmos to check your work. So here's how this might work. Part A, we've been done with. We're using an area model, hopefully, but you're just trying to factor this thing out. So the idea is we know you don't have to use the area model, but I'm going to, for the purposes of this video, I know that it's some kind of rectangle whose total area is x squared minus 6x plus 5. And I know that this upper right corner is definitely x squared, and this lower rectangle down here will be the 5. And I know what we called in class, we refer to these as the pink rectangles. They always combine to make that middle term. And so these two things can multiply to make x squared. I want to focus on things that multiply to make 5. And it has to work out in such a way that when I find the things that multiply to make 5, the pink squares combine to make negative 6. And this one you might be able to do without the area model, because not many things multiply to make 5. Our only choices are 5 and 1, and they both have to be negative, because then I would have negative 1 times negative 5 is positive 5. This would be negative 5x area, and the area of this would be negative x, and negative 5x and negative x do combine to make negative 6x. So part A, factored form of this quadratic is going to be x minus 5 times x minus 1. Now for part B, we're going to do that whole completing the square thing. So it's another area model, but we know for sure we're supposed to have a square. So it's going to be a situation where the x squared term is going to be a square part. Negative 6x is going to be in our square. And that 5, we're not going to worry about that off the bat, because we really want to focus on these things to make a shape that has to be a square. And the thought was, let's draw a thing that definitely has to be a square. So you'll notice I'm trying my best to make all the sides the same length. I'm drawing something straight down, drawing something straight across. And this time, what's different is I know that that has to be x squared, and I know that these have to be congruent. They have to be the exact same. Otherwise, it wouldn't be a square, and that's what I want, a square. So to get that x squared, the only game in town is to take an x and take an x. To get a negative 6x so that these two rectangles are the exact same, they have to take that negative 6 and basically chop it in half. So if I make this negative 3 and I make this negative 3, they're the same length. And this is negative 3x and this is negative 3x, so those do combine to make that middle term. I'm forced to do that. I have to take half of this value. I don't have a choice if I want this to be a square. And that means that this blue square has to be something really specific. If I'm forced to make these two pink lengths negative 3, this blue square has to be positive 9. So by doing that, I'm adding a 9 into the problem, but I don't really want to change the problem, so right away I'm going to subtract that 9 as well. And what happens is, this is the area of the square I've got shown here. And I can represent that area as x minus 3 squared. And then this part of things, I'm just going to combine these like terms. Negative 9 plus 5 makes negative 4. So what I have here is a second quadratic that's equivalent to the standard form, but this one has a binomial squared in it. That's the process, right? It's a lot of work, a lot of thinking. Then we're supposed to go over to Desmos and check our answers. So if I crack open Desmos, I'm going to graph all three of these things. And what I'm hoping to see is one graph right on top of another, right on top of another. And then I'm going to use that graph to fill in the grid. So that's going to look like this. X squared minus 6x plus 5. Oh, you can't see everything I'm doing. Hold up. So there's the original problem, x squared minus 6x plus 5. In the next one, I'm going to enter the factored form, x minus 5 times x minus 1. And I'm very pleased to see that that green graph is right over the blue graph. Right? I can get rid of the green graph and see it's the same. So yay, I factored it correctly. the same form, or same with quadratic in different form. And the last one is supposed to be x minus 3 quantity squared minus 4. So we're doing x minus 3 quantity squared minus 4, and yay, the purple graph also falls right on top of the graph that we had. And now I want you guys to transfer this graph to the grid, and I want you to pay special attention to these intercepts. Like, where is this thing crossing the x-axis? Where is it crossing the y-axis? And where is its vertex? So when I go back to the grid, I'm going to make sure I have a y-intercept at 5, x-intercepts at 1 and 5, and a vertex at 3, negative 4. Just do a nice pretty. So I don't want you to make a table or worry about all those different things. I just want you to pull the x, y, and vertex off the graph and throw it in the grid to see what's up. And that's it. Easy, right? So there's 4 more for you to do, maybe 5. I don't know how many I wrote. And good luck, good luck, good luck.